Okay, in this video, we're going to look at transformations being applied through the matrix method. So in another video, I've done mapping, the mapping method. So you can go look at the mapping method there if you like, but the matrix method also comes up. Neither are really that much more difficult or simple compared to each other. They're just different ways of thinking, I guess, but they both do the same thing. The only difference is how you set the equation up to start with. So you do have to remember you've got the original is xy, and that becomes x dash y dash. When you're using the matrix method, we use the transformation equation, and that's this thing I've got written here. Essentially, we need to be able to read this to understand what's going on. So x dash y dash, so it's saying the image is equal to the transformed values of x and y. So we're going to transform x and y to get the image. And that is described by this set of matrix equations here. So if you've forgotten how to do matrices, go look at the matrix video I put up there, and you should be able to follow along. So this matrix equation describes how you're going to transform x, y to get to the image. Now, these A, B, C, Ds, they all mean very particular things. This C is your horizontal translation. This thing here is your vertical translation. If C is positive, you're going to the right. C is negative, you're going to the left. If D is positive, you're going up. If D is negative, you're going down. Now the other ones, A, when I multiply this thing out, it'll be A times by X. So the A value is affecting your X value. That means the dilation of factor A from the y-axis. If it's affecting an x value, it's stretching it out horizontally. And if A is negative, it's a reflection in the y-axis. And this B is going to be a dilation factor of B from the x-axis. Not 1 over B, it becomes 1 over B once it's been in the equation, you can see that, but when you're putting it into your matrix method, whatever the dilation is stated, that is what goes in. It goes in there all the time. And again, if B is less than 0, it's a reflection in or about the x-axis. So you use the transformations, expand the matrices. Once you've expanded it, it becomes the same as the mapping method. You put the image x dash y dash equal to the transformation equation, and then you get x and y by themselves. So these two examples are exactly the same as in the mapping video, but this time we're going to use our transformations with our matrices. So x dash y dash is the transformed version of x and y, and that equals to our matrix. We've got 0 there and 0 there. You've got x, y here, and then you've got your C, your D there. So dilations go here, translations go in there. But of course, we have to make sure we're a bit careful of any kind of BODMAS going on in order. So let's look carefully here. The first thing that's happening is a translation of 1 unit up. So that means this D value from before is +1. Second thing is a translation of 3 units left. So that is our C value will be -3. Now notice that's what happened first, which means we need to put brackets around there. So we're doing a translation first, and then we are applying the dilation of factor 2 from the x-axis, which we know is this bottom corner. That is our B, and a reflection about the y-axis, which is A, and that makes A -1. If there's no dilation, it's just 1. Okay, that's our first step. Our second step now is to multiply out our matrices. So we're going to leave the -1, 0, 0, 2 as it is. and we simplify these. So these are both 2 by 1 matrices. So you get x minus 3 and you get y plus 1. And then we expand this pair of matrices out. So negative x minus 3 and 2 bracket y plus 1 equals x dash y dash. And at this point, you can say x dash equals negative x take 3. And transposing that to get x by itself will leave you with 3x dash. You divide by -1, so you have a -1 over here, and that disappears. And then you add the 3 across. The other one, we have y dash equals 2 bracket y plus 1. So we divide by 2 to get 1/2 of y dash, and then we subtract 1. And it's these two things that we substitute into our equation. So y is replaced with all of this, and x is replaced with all of this. So y equals root x now becomes 1/2, oh, not root x, sorry, x squared. I've jumped ahead to the next question. Y equals x squared now equals 1/2 y dash minus 1. Instead of x, we now have 3 minus x dash squared. We add 1 across. Dash still there. And then we times by 2. Like that. Now you can also write that as x dash minus 3 squared plus 2, because 3 minus x dash is the same thing as negative of x dash take 3. Now if I square this thing, put squared there, and squared therefore around the whole thing there, that -1 gets squared, and -1 squared is just +1. So you end up with that there. But this here is our equation of the transformed, our image. This is the equation of our image, the transformed equation. Let's move on to the other example. Now this one we have to do in a couple of steps, because we got a reflection, which is a multiply, then a translation, which is an add or subtract, then a dilation again, which is a multiply. So what we need to do is do this in a couple steps. This is where the mapping has a bit of advantage. You don't have to sort of do a double whack here. So we can do the first 2 steps together, because you've got multiplication and then addition. That works out all right with our standard set of mapping like this. But then at the end, you then have to multiply again for the dilation, but we'll get there in a second. So first of all, reflection around the x-axis, that is our b value. That's down here is -1. Then we have a translation of 4 units left, so that's -4, that's our C. And our 2 units down is our D, so -2 goes there. I can't go and chuck 1/3 in there now, because it's really important that we remember that this x minus 4 here, that forms a coordinate that is then dilated by a factor of 1/3. So for now, I have to leave it as 1/3. And essentially, I'd take all of this and then I multiply it by an extra matrix at the end, but we'll get there in a second. So you get 1 times x is x, -1 times y is -y, like this, plus -4, -2, and you end up with x minus 4, -y take 2. That is for the first 2. They're done. We've now got to do the last one. And the way we do the last one is we treat this thing kind of like it was sitting there. So we now have our final image. Our final image, x dash y dash, is going to be equal to a dilation matrix multiplied by something that has already been transformed. Now it's 1/3 from the y-axis, which is top left corner here. And then the bottom right-hand corner, nothing changes to 1, which now gives you, if I expand it out, 1/3 bracket x take 4, which is what should have happened because we translated, then dilated, and then the negative y take 2 doesn't change at all. Once you have that, we can continue on like we did before. You have x dash equals 1/3 x take 4, and you have y dash equals negative y take 2. To get x by itself, you multiply by 3, give you 3x dash, and then you add by 4. And the order is very important. As we discussed before, that will give you a different value. That would probably give you 12, I think, if you had got the 1/3 in the wrong spot. Now to get y by itself, you can add y across and subtract y dash, and you end up with that there. And at this point, this is where we substitute our values in. So y equals root x now becomes negative y dash minus 2 equals square root of 3x dash plus 4. And then we solve for y dash. So 2 plus, you could put the plus 2 at the end. That doesn't matter. So y dash is negative 2 minus square root of 3x dash plus 4 like that. And that is the equation of our image. Don't forget the domain and range can change in the same way. So if I have domain and range given to me in a question and asked to transform as well, you will transform your domain by using this transformation here. So you would, if you had a domain of 0 and to 3 like this, you would substitute x equals 0 in, and that'll give you the new end value. And x equals 3 in, and that'll give you the 2 new end values for your domain. And you do the same thing with the y value, you substitute it in. So your domain and range will change as well, and you can use the matrix equation there or the mapping equation to find the new domain and range. But that is how you transform equations using the matrix method.